Drifting silently through the vast, lightless expanse of space, Voyager 1, a spacecraft no bigger than a compact car, is now more than 14.5 billion miles from Earth. Launched back in 1977, its original mission was modest by today's standards, a 5-year journey to explore the outer planets. Yet nearly 5 decades later, it's still operational, defying both expectations and time itself. However, in recent years, scientists have observed something deeply unusual. Voyager 1 has begun sending back strange pulses, signals, and patterns of data that defy explanation. The question now hanging in the silence of space: did Voyager discover something out there in the starless void? Or, perhaps more unsettling, did something find Voyager? The story of Voyager doesn't begin with rockets or launch pads, but with a rare alignment of the outer planets. In the early 1970s, astronomers realized that Jupiter, Saturn, Uranus, and Neptune would soon arrange themselves in a perfect formation that occurs only once every 175 years. This event would make it possible for a spacecraft to visit each planet in succession, using gravity from one to slingshot to the next. This extraordinary opportunity was too good for NASA to pass up. So, they initiated the design of two identicals spacecraft capable of enduring the high radiation near Jupiter, the icy risks of Saturn's rings, and the long, uncertain voyage through the outer reaches of the solar system. This was the beginning of what was then called the Grand Tour, later renamed Voyager. The Voyager spacecraft were marvels of 1970s engineering. Each probe weighed around 1,800 pounds and carried 11 scientific instruments. They weren't powered by solar energy, far too weak that far from the sun, but instead used radioisotope thermoelectric generators, or RTGs. These nuclear batteries generated electricity by converting heat from the slow decay of plutonium-238 into power. With no hope of repairs after launch, the engineers had to make the spacecraft as self-sufficient as possible, with multiple backups and systems that could identify and correct their own malfunctions. Their onboard computers had only about 68 kilobytes of memory, less than what's needed to store a single digital image today. Voyager 2 launched first on August 20th, 1977 from Cape Canaveral, followed 16 days later by Voyager 1 on September 5. Even though it launched later, Voyager 1 was on a faster path and quickly overtook its twin to become the first to reach Jupiter and Saturn. As these small robotic emissaries left Earth, few could have imagined that decades later one of them would still be out there, making headlines, not for what it was observing, but for what might now be observing it. After about 18 months of travel, Voyager 1 reached Jupiter in March of 1979. What it found there changed our understanding of the gas giant forever. Through Earth's telescopes, Jupiter had always appeared as a striped orb with a curious red spot. But Voyager revealed that those stripes were actually immense bands of storms and jet streams racing at hundreds of miles per hour. The Great Red Spot turned out to be a massive, churning storm system big enough to swallow Earth several times over. Yet it was Jupiter's moons that delivered the greatest surprises. Io, the closest large moon, shocked scientists by showing real-time volcanic eruptions. Volcanoes unlike any on Earth, spewing sulfur compounds instead of lava, coating the surface in vivid yellows, oranges, and reds. Then there was Europa, a smooth white moon crisscrossed by fractures and ridges. Voyager's images led scientists to theorize that beneath Europa's icy shell might lie a liquid ocean, a potential haven for alien life. Voyager 1 continued on to Saturn, reaching it in November 1980. From Earth, Saturn's rings had always appeared as simple, solid bands. Up close, they were anything but. The rings fractured into thousands of smaller ringlets, some braided, others dotted with mysterious spokes. each part of an intricate and ever-shifting cosmic dance. Saturn's Moon Titan also drew intense interest. Unlike any other moon in the solar system, Titan had a thick atmosphere. Though Voyager's instruments couldn't see through the orange haze, they determined the atmosphere was primarily nitrogen, just like Earth's. This clue paved the way for future missions, eventually confirming that Titan has lakes and rivers of liquid methane. After its Saturn encounter, Voyager 1's planetary mission was effectively complete. NASA had a choice: send it onto Pluto or direct it out of the solar system. They chose the latter, steering it northward out of the solar system's plane and into interstellar space. As it departed, Voyager 1 turned its camera one last time toward the inner planets. In February 1990, at Carl Sagan's request, it captured a now famous series of images, including Earth as a faint blue speck, the pale blue dot, suspended in a beam of sunlight from nearly 4 billion miles away. Sagan's reflection on that image remains one of the most moving commentaries ever written about humanity's place in the universe. From that point on, Voyager 1 went blind, its cameras shut off to conserve power. But its mission wasn't over. The spacecraft continued to monitor the invisible environment around it, listening and measuring the conditions in the dark between stars. And mounted to its side was something extraordinary: the Golden Record. Each Voyager carries a 12-inch gold-plated copper disc, a time capsule from Earth. Known as the Golden Record, it was meant as a greeting to any intelligent life that might, someday, find it. The team led by Carl Sagan had only 6 weeks to decide how to represent all of humanity. The result was a collection of greetings in 55 languages, some ancient, some modern, alongside sounds from Earth, including thunder, wails, footsteps, laughter, and a human heartbeat. The record contains an eclectic selection of music, from Bach to a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. There are also 116 images showing everything from DNA to human life and nature. The instructions for playing it, along with a pulsar map locating Earth, were etched on the cover. Though the odds of any alien civilization ever finding a Voyager are minuscule, the gesture itself was symbolic. An optimistic shout into the cosmic void, saying, "We were here." Decades passed, and as newer missions grabbed public attention, Voyager continued on, steadily, silently, covering nearly 1 million miles each day. Scientists weren't sure exactly where the solar system ended, but they knew it was surrounded by the heliosphere, a vast bubble formed by the solar wind pressing against the interstellar medium. Voyager 1's data helped map this boundary. It tracked fluctuations in solar wind, magnetic fields, and cosmic rays, feeding vital data back to Earth. But survival wasn't easy. Its power source, a supply of decaying plutonium, grows weaker by 4 watts every year. NASA's engineers were forced to shut down one system after another, including the cameras in 1990. Communication became a challenge, with signals taking over 14 hours to reach Earth. Only the largest antennas in NASA's deep space network could pick them up. By the early 2000s, the spacecraft approached the edge of the solar system. In 2004, Voyager 1 crossed the termination shock, where the solar wind slows abruptly as it pushes against interstellar space. For 8 more years, it journeyed through a chaotic region called the heliosheath. Then, on August 25, 2012, everything changed. The magnetic field suddenly intensified. Solar particles dropped, while cosmic rays surged. Voyager 1 had crossed the Helopause, the official boundary where the sun's influence ends. For the first time in history, a human-made object had entered interstellar space. But what Voyager found beyond the Helopause was not what scientists expected. Interstellar space wasn't empty and quiet. It was teeming with activity. The plasma was denser than predicted. The magnetic field didn't shift direction as expected. It aligned the same way, only stronger. Voyager was being bombarded by cosmic rays from all directions, in strange and unpredictable patterns. Even more puzzling, the spacecraft began detecting wave-like oscillations in the surrounding plasma, regular repeating patterns that shouldn't have been there if they came from the sun. These tsunami waves, as some called them, hinted at a far more dynamic interstellar environment than anyone had imagined. At first, these anomalies could be rationalized. Perhaps they were echoes of ancient solar flares or natural turbulence in the interstellar medium. But by 2017, that explanation no longer fit. The waves weren't fading with distance. They were forming complex mathematical patterns with harmonics and structures that suggested something far more intentional, or at least far less random, than nature usually provides. Voyager was now passing through something strange, something structured, out in the interstellar dark. Then, in late 2017, the mystery deepened. NASA engineers monitoring the spacecraft's orientation systems noticed a baffling inconsistency. Voyager's control system, which keeps its antenna pointed at Earth, was reporting that it was no longer aligned. Yet the signal coming from Voyager was still perfectly strong and stable. It was as if someone claimed to be calling you from the other side of the planet, but the phone number on the screen showed they were just next door. Initially, engineers thought it was a glitch. Understandable after 40 years in deep space. They sent commands to run diagnostics, hoping to reset the system. But the strange behavior continued. Voyager was somehow still sending a clear signal, even while reporting it shouldn't be able to.